In this lesson we're going to be looking at perimeter, and as my two cats here are kindly demonstrating, perimeter is a measure of distance, and it's the length or distance around the outside of a shape. I just can't stress the difference between perimeter and area. Perimeter is the length around the outside of a shape, and area would be how big is the cushion on the middle of this little cat bed here. So please bear in mind, perimeter is a length and area is a measure of how much space is in between or in the middle of a shape. Okay, perimeter has relatively simple calculations, so because of this I'm able to show a few examples of some different ways you'll be asked to work out the perimeter, and we can go through them quite quickly, get a feel for what is going to be involved in the work and on the tests, as well as cover all that we need to cover. So the most basic form of calculating a perimeter is you're given a shape and every single length of the sides is given to you. So perimeter is just a case of adding them all together, and it is my little hint to you to mark off the lengths as you've got them. So 4.7, we've got that one. We write 5.3, we cross that one off. 12.3, that one goes, 11.2, and 5.6. The reason behind that is when you're doing a test, you're sort of under a bit of pressure, and the more sides and varying lengths that this shape has, the more chance you've got of just trying to breeze over what looks like a relatively easy question, and you make a simple mistake where you lose your marks. So marking them off as you write them in your little working out section there will help to save you some marks in the future. So we add all those up and we just get the length around the outside of that shape is 39.1 centimeters. Getting a little more difficult is when the shapes give you information not just in numbers but in the symbols that they have. So here every side has a single line on it, so that means every single side of this shape is as long as this one is here. And what we could do is we could go 5 plus 5 plus 5 plus 5 plus 5 plus 5 and mark each side off to make sure that we've got it. Or we can just realize that there's 6 sides to this shape, they're all 5 long, 6 times 5 gives us 30. And that's it. It's important to note that this question didn't give us any units, so that's not centimeters or meters or anything. So you need to bear in mind when you do your answer to make sure you write units at the end of it to show you understand that it is a length answer that you're getting. Similarly, if you were trying to work out the area of this shape, you would write units squared at the end of it if they didn't give you any information. But more often than not, they'll give you 5 centimeters or 5 meters and tell you what it is. Okay, stepping it up a little bit. This is here, it's a little more of a complex shape. As I say up here, it looks like a bunch of shapes have been glued together and you have to work out the perimeter of this one. It's important to note that you're missing some side lengths, so it's not as simple as just going ahead and adding up every number you've got, because you're going to miss this length here and this long length over here. So you do need to keep an eye out for that. Okay, what I did was I labelled this side here A, and the way I worked out A is from one end of the shape to the other is 30 long. And over this side we've got 12 plus our A plus our 8 get us the same length as 30. So if I take that 30, get rid of the 12, get rid of the 8, it's going to leave me with the side that I need left, A. So A is 10. Same thing for this side over here, I called it B, and what I've got is B is the big long side, but if I take this side length here of 11, this side length here of 3, and this one of 6, because they're all running parallel with my side length B, add all those 3 up over here, and it gives me B is a length of 20. Then it becomes a case of pulling every number, adding them all together, and remember, it's better to start systematically, so I started here down at the 30, and then I go around the shape. So I'm not trying to confuse myself by trying to add 30, then 8, then 12, then 6, and I just forget what numbers I've got. Start with one corner and work your way around the shape. 30, 20, 12, 6, A, which was 10, 3, 8, and 11. Add all those up, and I've got 100. Again, nothing was specified, so I have a perimeter of 100 units. So relatively simple so far. Stepping up the difficulty again, we've got the tried and true formula of Pythagoras, where you will need to use that formula to work out an unknown length of a triangle to help you work out the perimeter. So at the moment, I've got a right angled triangle. Remember, Pythagoras only works with right angles in triangles. I've got a side length of 3 plus a side length of 4 plus my side length of c. Okay, Pythagoras' theorem, c squared equals a squared plus b squared. Quick refresher. C is always the hypotenuse. The hypotenuse is always opposite the right angle. So here's the right angle, and that's the side opposite the right angle, and it's also the longest side of the triangle. So we're looking for C in this case. So we need to go ahead and use Pythagoras' theorem, sub in our values. Doesn't matter which one's A and B, we're just adding those numbers together anyway, and if you've got 2 plus 3, that gives you 5, or if you've got 3 plus 2, it still gives you 5. So you can pick A and B as to whatever size you want. So we've got 3 squared plus 4 squared, subbing in our two other sides. That gives us 9 plus 16, 25 all up. So that means that this side here squared equals 25. So we need to square root that number, and it'll give us 5 meters for the length of C. Once we've got that, add all three lengths together. 3 plus 4 plus 5 gives us our perimeter of 12 meters. So that should be just a refresher for most of you. Okay, stepping it up again, we have circumference. Now circumference is just another word for perimeter of a circle. It's the length around the outside of a circle, and there's two ways we can work it out. The most basic way is that you get pi and you multiply it by the diameter. Now remember, the diameter goes from one end of a circle through the center and straight out to the other side of the circle. With circles, as you can see here, we also can be given radiuses as information, or radii. And because the radius is just from the center of a circle to the edge, we can say that 2 radiuses make a diameter, so we can alter the formula slightly to suit information that we're given and be able to calculate the circumference without having to adjust too much. So we'll start with our easiest example first. The circumference of a circle, or the length around the outside of it, is equal to pi times diameter. So this question here, the diameter is 20. So just filling out the formula, circumference is pi times diameter, pi times 20. Plug that in on your calculator, 62.8 meters. Getting a little more tricky when they only give you the radius. We're going to use the radius formula. 2 times pi times a radius. So have a look, 2 times pi times 8.5. Plug that straight in your calculator, you're left with 53.4 meters. Nothing too difficult, and just a couple of simple formulas for you to remember. Okay, sometimes they're not always going to be full circles, unfortunately. So we're going to have to adjust what we do to suit that, and we have to think very carefully. So in this question here, what we've essentially got is half a circle in its curved length, and we've got a straight side down here. And I apologize, I'm not very good at drawing arrows with a mouse. So the perimeter of this is equal to half the circumference of a circle plus the diameter of the circle. So we need to work out those bits. The diameter is pretty easy. It gives us the diameter, 3.7 centimeters. Circumference, a little harder to work out. We need to use pi times diameter, but because we only have half a circle, we need to half our actual answer. So we go ahead, the diameter is 3.7, so a half times pi, because we only have half a circle, times the diameter of 3.7, gives us 5.81. Putting that together to get our perimeter, 5.81, our half a circumference, plus 3.7, our diameter, gives us 9.51 centimeters. The other one is, so that's for a semicircle. The other one is a quadrant. So working out the perimeter of a quadrant, what we need to do is identify the bits that we've got. So I'm going to go back to green, and we only have a quarter of the circumference of a circle, and we have 1 radius there and 2 radius there. So remember, a quadrant, this is the middle of the circle, and we are given the length from the middle of the circle to the edge, and that's 5.3, so we know we're given the radius, and we know that this length here is also the radius, given that these two lines here denote that this length here is the same as this one here. So to go ahead and work out the perimeter, we need to work out a quarter of the circumference and then add on 2 radii. The circumference bit's the hard bit. Because we're given the radius, we need to use the 2 pi r formula for the circumference. We only have a quadrant, or a quarter of a circle, so we only get a quarter of the actual formula. Putting in our information, a quarter is a quarter, 2 is 2, pi is pi, the radius is 5.3. So in it goes, we multiply all them together, and we get 8.32. To get our total perimeter, it is our 8.32, or the quarter of a circumference, plus 1 radius, plus another radius, to give us 18.92 centimeters as the total length around this quadrant here. So it's easy to fall into the trap with these two of just going straight for the formula, and maybe even you remember to adjust the formula and realize you've only got half a circle or a quarter of a circle, and you work it out. But a lot of people stop there and they say, yep, that's the perimeter, and they forget about all the straight edges, so the diameter on the semicircle and the 2 radius on the quadrant, because it's not something they're used to doing with circles. So you need to remember to take into account and mark off every side when you actually account for it in your final calculation. So you ensure that you've actually added up every single side that there is in the shape. Okay, our last few examples are some worded ones, and this first one here is, how far will this wheel here travel in 1 revolution? Now remember, a revolution is a full rotation of the circle. Because this is a tire, it's important to note that 1 revolution of a tire is equal to how far it will travel. And what I've done is I've got a little video here to show you. So we have a circle. That line started down the bottom. It's rolling all the way around, and it ends up back down the bottom. We'll unfold the length of the shape, and you'll see that the circumference of the circle is equal to 1 full revolution. So that's just a little video there to help demonstrate what I'm trying to talk about, because it's hard to explain. So what we've got is essentially a really hard way of asking us to work out the circumference of this wheel here. Circumference, pi times diameter, because we're given the diameter, pi times 80 centimeters, 251 centimeters. The question asked us something in words, so we need to answer in words and say this wheel will travel 251 centimeters in 1 full revolution. My last and big question is these two here. So we've got the Earth and the diameter of the Earth, so from one side through the middle all the way to the other side of the Earth is 12,756 kilometers. And this question here, find the circumference of the Earth to the nearest kilometer. So what we need to find out is the distance all the way around the Earth if theoretically the Earth had that as its diameter. So that's pretty straightforward. Let's just work out the circumference. Pi times diameter, because we're given the diameter. Pi times 12,756 kilometers gives you 40,074 kilometers. So given that it's about 3,000 kilometers from here to Perth, that's quite a few trips from here to Perth to get all the way around the world. But it's not as big as what I first thought. Okay, part B. A space lab orbits the Earth at a height of 1,200 kilometers above the Earth's surface. Find the distance it travels in 1 orbit. So I got a little picture here to help us out. And I'm going to put my space station here. This dotted line is its orbit path, and I'll get rid of the green one so it's not as confusing. And what we've got is this space station floats around our Earth. And it's always, as the question states, 1,200 kilometers above the Earth's surface. And it's always doing that. So what we need to have a look at is, what is the new diameter? So from the edge through the center of the Earth all the way to the other edge, what is that length? Now, because and it's floating at a height of 1,200 kilometers above the Earth's surface, that means up here there is 1,200 kilometers. But it also means that there's another 1,200 kilometers at the other end of the diameter when it's floating around that section. So this, when it says that it floats at a height of 1,200 kilometers above the Earth's surface, that's actually only adding 1,200 to the radius. And if you want to be able to use this simple formula here, you need to account for the fact that it floats high above Earth over here at 1,200 kilometers, and when it's at the other end of the diameter, it's another 1,200 kilometers above the actual Earth's surface. So putting that in, we've got an original diameter of 12,756 plus 1,200 plus 1,200, which gives us 15,156. Multiply that by pi to give us a distance of orbit as 47,614 kilometers. So just a little bit of a light fact of how far space stations actually travel. That's the end of perimeter. We've covered quite a lot. I hope it's gone well for you, and I will see you in the lesson.